Welcome to part one of a really fun section of Algebra 1. I love this stuff. I'm also weird, but whatever. Solving systems of equations. Part 1, solve by graphing. So here we're solving something called systems of equations. What that basically means is we have two equations. Something like, let's see. Let's see here. And that sounds good. So y equals 2x plus 1, y equals negative x plus 4. This is called a system of equations because we have two or more equations that you have to solve at the same time. That's right, we're going to be finding values for x and y at the same time. I will now pause for your crying. Okay, I'm back. So, what we're trying to find here basically is a point of intersection. Remember, these are equations of lines. Lines are made up of an infinite amount of points. So somewhere is a point where these two lines cross each other. That point of intersection, that is your solution. Because you plug the point in, it's on both lines. It makes both equations true. So that is what we're trying to find out. So there are different ways to do this. Part 1's graphing. We're going to cover elimination method. And I don't think we do matrices in this course. Let me just double check real quick. No. We use substitution. So part 1 is graphing, part 2 is substitution, and part 3 is elimination method. We'll spend a couple days in each of these methods, so don't panic too much. Graphing is the one we don't really use a whole lot, only because when you start getting into the bigger numbers, you don't want to try graphing those. It gets annoying really fast. So in my examples here, I'm going to keep the numbers small. I don't want you to try to graph things like 4, 100. That's just too painful. So to solve by graphing, it's extremely simple. First things first, make sure each equation is in slope-intercept form. And if you've forgotten that already, slope-intercept form is y equals mx plus b. So make sure they're both in that form. Sometimes they are, sometimes they're not, and you have to rearrange them. It just depends on the problem. In this case, they both are, so we are happy. So now we're going to graph each equation. So I'm going to graph the first equation by itself, y equals 2x plus 1. So I go to my grid. Let's use red, it's easier to see it. So 2x plus 1, that's this equation over here. And we had y equals negative x plus 4. So graph the first one. First of all, go your y-intercept, that's plus 1. So go up to 1 and put a point. And now your slope is 2, which is 2 over 1. So up 2, right 1. And you want to make several points here because you're trying to find where lines cross. You can always add more points if you need to. But I usually make 4 or 5 points to begin with. If I need to go lower, I can't go down to left 1. Just remember that. So for now, those are my points. I've got a line forming. Technically, you're supposed to connect the dots and make a line. So I shall go ahead and do that. Let me see here. This should work nicely. Yeah, that's nice and pretty. Shoot over there. And there's your first line so far. I don't usually connect the dots when I'm done with the problem because if I have to add more dots on, it just gets irritating. Whatever. Let's graph the second line now. So negative x plus 4. So your y-intercept is at positive 4. So go up to 4. 1, 2, 3, 4. Your slope is negative 1. So that's negative 1 over 1. which means down one, right one. So down one, right one. And just like that, we've already found our point of intersection. If I kept going, I would have this line here. I have already found the intersecting point. I lucked out, found it very, very quickly. And that point is 1, 2, 3, 3. So my solution is 1, 3. You need to check your solutions. When the graphing, not as much because, you're graphing. But you still need to make sure you didn't graph incorrectly. The other two you need to definitely check. Plug your answers in. The answer must make every single equation true. So if it works in the first equation, but not the second one, it is not a solution. It has to make every equation true. When you get into 3x3 systems, which will probably be in Algebra 2, you have to make all three equations work. So all you have to do is take your equation and plug it in. So y equals 2x plus 1, y equals negative x plus 4. Our point was 1, 3. So plug that in. 3 equals 2 times 1 plus 1. 3 equals 2 plus 1. 3 equals 3. First equation checks. 3 equals negative 1 plus 4. 3 equals 3. Second equation checks. So your solution is indeed 1, 3. That's literally all this takes. You graph both lines on the same graph. You find the point where they intersect. You plug it in to confirm that it works. And you're finished. That's all there is to solve for my graphing. Graph each line. If you can graph lines, this will be no problem for you at all. Now, if you have a problem graphing lines, well, that might be a teeny tiny issue. But, we'll keep that kind of hush-hush right now. Shh. It's not a big problem. Well, not that big a problem, I suppose. All right, let's try that one here. Y equals 2x minus 3. And y minus x equals negative 1. So first things first is get them both into slope-intercept form. The first one already is. The second one is not. So you have to move that x over. And you get y equals x minus 1. And that's what we want, slope-intercept form, so we're happy now. So we're going to ignore this one. It's not here anymore. It got transformed. So here are your two equations you're going to graph. 2x minus 3 and x minus 1. So to the graph we go. Let's see here. 2x minus 3 and x minus 1. Correct? Yes. Graph the first one. So down negative 3. 1, 2, 3. Slope is 2. Up 2, right 1. Up 2, right 1. Up 2, right 1. Good enough for now. Second one, go to negative 1. Slope is 1, so 1 over 1. Up 1, right 1. Let's do this real quick here so you can see it. So it's not crossed yet. Looks like it's about to, but it's not there quite yet, so let's keep going. Up 1, right 1, and there it is. It is crossed. And that is it. 2, 1. So let's go back and confirm that it works in each of them. 2, 1. So 1 equals 2 times 2 minus 3. 1 equals 4 minus 3. 1 equals 1. Yes. 1 equals 2 minus 1. 1 equals 1. Yes. So your solution is indeed 2, 1. See, that's all it takes. That's really how easy it is. All right, so far so good? Yes? No, put your hand down. No, not you. The other person. No, not you. Yes, you. Put your hand down. We'll get that in a second. So next topic we have up is not necessarily any harder or any easier. It's just, tied into it. You will have times when there is no solution. And you will have times when there are infinite solutions. Now it sounds kind of weird. So let's look at each one of those real quick. First of all, we'll go with no solution. No solution basically means the lines do not cross. Now, as we know, in a two-dimensional plane, the only time lines don't cross is if they're parallel. If your lines are parallel, they do not touch, which means there is no solution to a system. It's just not going to happen. We need an example of that. Y equals 2x minus 1, y equals 2x plus 2. If we go and graph those, see 2x minus 1, so here's 1, up 2, right 1, up 2, right 1, up 2, right 1. Let's grab Sparky here. Draw my line. And then I have 2x plus 2. So up 2 right here. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Those lines do not cross. They're not going to cross. They're parallel. That means there is no solution to your system. The way to tell very, very quickly is look at your equations. Get them both in slope-intercept form. Now, parallel lines have to have the same slope, which we discussed that a while back in graphing. So look at your slope. If these numbers right here are the same, the lines are parallel and there is no solution. Don't even bother graphing it, because you know they're parallel lines. You know there's no solution. So don't even bother trying. Now, if you do try and get parallel lines, okay, fine. Great, but just know that if your slope's the same, there's no solution. Now, the other type was infinite solutions. And what that basically means, let's say you had 2x plus 4y equals 8, and eeny, meeny, miny, wombat, y equals negative 1/2 x plus 2. First of all, slope-intercept form. So this one's good, this one's not. So let's see, 4y equals negative 2x plus 8, divided by 4. Y equals negative 1/2 x plus 2. So this has been rewritten now. Now your second equation is down here. But if you look at it, it's the exact same equation. If you graph them both, you're going to get the exact same line. It's the same equation. Since you have two lines that are the same, they intersect at every single point, because it's the same line. That means there are an infinite number of points that work. Therefore, there are infinite solutions. That's all it means. It's the same line. So you do your equations, you get in the slope-intercept form. If you have the same equation, your answer is infinite solutions. Some textbooks say infinitely many solutions. Same thing. There are an infinite number of solutions. That's basically three options. You have a solution, you have no solution, or you have infinite solutions. That's it. So that was fun, I'm sure you had a great time with that. We will carry on with part 2, substitution. Oh yeah, you'll love it. Lots of